Hey everyone, how's everybody doing? In this video, we will cover topic 13, which is similar shapes, and then I will have one more video to cover topic number 14, which will be cross section, and that will end section number 11, the 3D geometry. Then, after that, we will go ahead and review and test for the end of the year. So, stay with me, we're almost there. Hang tight, okay? All right. So this lesson talks about similar shape. So we did talk about similarities before when we did triangles. It's kind of the same process, but it's a little different since we are dealing with 3D versus the triangles were only 2D. So before we get started, let's go ahead and define what's a similar solid. What does that mean? Well, similar solids do have the same shape. For example, when I'm comparing uh, shapes, when I compare shapes, I cannot compare a cylinder with a prism or a sphere with a cone. They do have to either be two cones, two prisms, two spheres, two cubes. So they must be the same shape. And their corresponding dimensions are proportional. So I forgot an R. And their proportion. Their what it means by proportion, they are scaled by the same scale factor. So it's either multiplied by 2, divided by 3, or so they're always going to be proportional. The ratio of the corresponding linear dimensions of two solid is normally defined by K. Um, okay, or we use A over B sometimes, or sometimes we do A to B. Okay, so K is really the scale factor. Okay, so K is the scale factor. K is equal to A over B, and then A over B is the same as A colon B. They can give you that way. They can also tell you A to B. They can say 4 to 7. They can say 3 to 2. You just have to understand that this is all just different ways of expressing what a scale factor is. So let's go ahead and decide based on the figures given. Are the two solids similar? That's not what I meant to do. I wanted to highlight that. So are the two solids similar? If so, state the scale factor from the first to the second. Now, how do I know the scale factors? How do I know if the solids are the same? So there is one thing you should remember from when we did the scale factor for dilation. It really is the same. The scale factor is new over old. For me to find the scale factor, I must use new over old. So it is a scale factor of the first to the second. So, in your opinion, the first figure and the second figure, which one should be our new and which one should be our old? So since we're going from the first to the second, the first becomes our new, and I'm going to use N for new. And to the second figure, then the second figure is our old. Oh, I'm sorry, it's the other way around. So from the first figure to the second figure, I really did mean the first figure is the old figure. I'm going to use O for old. And the second figure, I'm going to use N for new. So second figure, so here's our old, here's our new. And since we are trying to figure the dimension, please, there must be corresponding. So I cannot use an L length with a W with width or length with height. It has to be a height with height, length with length, um, width with width. So for example, if I look here, this 6 right there is corresponding with 3. I'm gonna color code them because it's really important to know if you don't know them. And then the width right here is corresponding with the width here, 4 and 2. And then maybe we can use pinkish to see, or purple, the height corresponds with the height. So first, let's find out. What's the scale factor from new to old, height to height? So let's do that. For the height, we have height to height, new over old, that would be 6 over 3, and that will give us 2. Now let's try the W. Let's see if I can get a green pen. That might, color code is it does help a lot. So let's do the length. In this case, it would also be 6 over 3, which will give you a scale factor of 2. Again, it's new over old, that's why what I'm doing. W should be the same color we had earlier. I should change that color. So W should be 4 over 2, which is 2. And I'm going to trace this in that color. It's not the same, but similar. Notice that the scale factor is the same of all 3 dimensions. So the scale factor is 2, and we also notice that the old become bigger. We see the scale factor is greater than 1, makes an enlargement that happen in the factor. So yes, they are similar. Okay. I'll skip the next prism. You can try it on your own to find if they are similar or not. Pause the video, see if you can try that again. L with L, H with H, W with W. I'm assumed that you have tried this on your own. The scale factor here did not come to be the same, so therefore not similar. And instead of doing the next cylinder, I'm going to go ahead and do the last cylinders. Now, I know in the cylinders we don't have L, W, and H, but we do have H and R. Dimensions are quite different, but again, the process is fairly the same. So R here is 7, R is 3, and I have 22 of a height of the big cylinder, and I have a 9 of the smaller cylinder. Again, they must be corresponding dimension. So we'll do the height first. Let's see. So we have old and new. Let's do that one too. So the first figure is our old, and the second figure is our new. So it's new over old, 22 over 9. New over old, 22 over 9. And then we do R. R is also a dimension, so please be careful with that. Okay, so it's 7 over 3, new over old, 7 over 3. Now, we don't know really if these are the same until we find them in decimal. I think the best way is to find them in decimal, but you can look at the fractions. Can the 22 over 9 be simplified to become 7 over 3? In other words, can the 22 over 9, is there a number that goes into 22 and 9 at the same time to give us 7 over 3? No, so they will not be the same. But if you don't know how to do this, you can easily divide. 22 over 9 is 2.44, so it's 2.44 repeated. And then 7 over 3 is 2.33 repeated. You see that the scale factor isn't the same, therefore the figures are not similar. Okay? So I just wanted to do an example of each to show you the not similar and the similar. If you tried the ones I skipped on your own, and you'll notice that 10 over 12 will be the same as 5 over 6 once you simplify them, so they will be similar. So this example, they are similar. So the key here is to make sure the scale factor is exactly the same. And once you find the scale factor, you can compare. Remember, corresponding dimensions only, which means height with height, radius with radius, diameter with diameter. You can't do a height with width. You cannot do a length with height. They must be corresponding. All right, so let's really talk about what this lesson is about. This is all introduction to the lesson. It's the easy part of it. So let's go ahead and see what happened. Can I actually find a scale factor of the volumes of solids or the areas of solids? Can that be possible? So it says areas in volumes of similar solids. Okay, so how are the areas in the volume are related if the solids are similar? So if the scale factor of two similar solid is K. Or again, we use A over B. Then the ratio of the corresponding areas is the square of K. So it'll be K squared or A squared over B squared. The ratio of the corresponding volume is K, and can you figure? Cubed or A cubed over B cubed. Okay, one more time. One more time. There's three ways we can talk about the scale factor. The first way, if what's the relationship of their dimensions? If I'm writing it wrong. And it's E. This is I. All right, one more time. Of their areas, volume. Again, how is the dimension, the areas, the volumes of similar figures are related. So first, the dimensions are proportional with a scale factor of K or A over B. Okay? Areas. K becomes squared or A squared over B squared. Volumes. K become cubed or A cubed over B cubed. Please know this. Okay, this is the key to answer any question in the upcoming one. All right? Okay, let's look at the examples. It says a square prisms are similar. So again, the key here is if they are similar. If they are not similar, we cannot use that ratio. What is the scale factor from the smaller prism to the larger prism? Remember, to find the scale factor, you must know what your new is and what your old is. So it does say from the smaller to the larger. So the smaller is our old. The larger is our new. So this is new, this is old. And if we go down here too, that's new and that's old. I will do both examples because I do want to show volumes and areas. So K, this or A over B, I'm going to use A over B for one problem and then K for the second problem. Okay, it's old, so it's new over old. And remember, these are volumes, so this must be cubed. New over old, so it's 1 over 729, new over old. Now, this is the cube of A over B. So how do I find A over B alone? I must take the cube root, okay? The cube root. So A over B would equal to the cube root of 13331,729. I do recommend to use the fraction key here. So here's what I would do. I would do 1331. And instead of the division key, use the fraction key, 729, and then don't press enter or anything. You have to do second. And the cube root, I don't know what is it on your calculator, but it should show in green above something, okay? The cube root should be above something. So once you do that, you get 11 over 9. Now, if you don't know how to do this on your calculator, please Google it. I'm unable to show it here for some reason, but I don't know what kind of calculator you're using at home either. So if you don't know how to get the 11 over 9, please Google it. Just put down the name of your calculator. Name of the calculator is usually on the top of the calculator. So the one I'm using at home is a Casio. So whatever you're using, and then say, how do I find the cube root of a number using Casio, using TI, and then make sure you filter to videos because it's easier to see on a video rather than see it, like read the instructions. All right, now let's try one with an area, okay? It's the same process, but remember for areas, A and B is squared. I'm gonna use K here. K squared is equal. New over old. New is 324. Old is 144. Okay, and again, to find k alone, I must take the square root here, since they're both squared. In the volume, we took the cube root. So k is the square root of 324 over 144 was 18 over 12. We can simplify the 18 over 12 by 6, and that will give us 3 over 2 as a scale factor. Okay, now some of you would ask, Miss, what if I write this in decimal? Well, it's okay. It's okay whether it is decimal or fraction. Okay, I really have no preference. All right. Let's do some more practice problems. Okay. It says the lateral area of two similar paints. So two similar paint cans. So one key that we already know, the paint are similar, the cans are similar. It's 1019 and 425 centimeters squared. The volume of the smaller one is 1157 centimeter cube. What's the volume of the larger one? Now, these are very common problems. So there's two steps to do this problem. This is not one step problem. First, you have to find k. You have to find k. You have to find the scale factor. And then two, we're going to use k to find the unknown. The unknown can be area, can be volume. All right? So I'm going to zoom out a little bit, and then I'm going to show you here on the side after we write down the given information. So it says 1019 and 425. Can you guess which one is the smaller? So we have a smaller area for a can because we have a small one and a large one. So we can write down that the area of the small can is equal to 425. The area of the large can is equal to 1019. And the volume of the smaller can is 1157. It's good to lay out the information. We need to find the volume of the larger can. That's our unknown. This will be eventually our x. How do I find k? So remember in the previous example, what I did is I found k using the two volumes or the two areas. We're going to do the same thing. Since the two areas are known, we use that to find k. Okay, I'm going to use that to find k. So again, it's areas, then k should be squared. So it's k squared equal. I always rather using area large over area small, unless it's specified otherwise. It's nice to just put area large over area small because it's easier to calculate. Okay, now what if I did the other way around, the area small over area large? It really doesn't matter. Okay, and I can show you what's the only thing that makes a difference. So k squared is equal. Area large is 1019. Area small is 425. Simplify. The only way we can find k is by taking the square root of both sides. Because I can only find k squared given that. But I only need k because I need to find k. So k here, you divide 1019 over 425 and do not forget to take the square root of the number you find. Okay, the answer should be 1.5. I just don't have enough space to write everything down, but from this step to that is nothing more than a calculator step. Okay, so our k now becomes 1.5. Now that I find k, can I use the k to find the unknown area or volume? Well, the question here really specified that the unknown is volume, large volume. We use the proportion again, but again, because it's volume, k must be cubed. K must be cubed. So k cubed would equal to also volume large over volume small. So in this case here, the only difference is if I had used area small over area large, then the volume down here would be volume small over volume large. Okay, but if I'm using large over small, then you keep the second step also large over small. In other words, be consistent with your scale factor. If you are not consistent, it's very hard to get the right answer. All right, so what's K? 1.5 from step 1, okay? And it's cubed equal. Volume large, unknown, Rx. Volume small is 1157. Now, remember X is on the top. What do? I multiply these two together. Okay? So 1,157 times 1.5 cubed should give you volume large, which is X. What is it? 3,904.9 centimeter cube. Let me just really quick double the math here. I don't know why this doesn't sound right. Times 11.57. Okay, there's no point. Yes, 3,904.87, so it would be 0.9. Okay? All right. Let's try one more. The process doesn't change, it just becomes a bit manipulative. Okay? So let's go ahead and read this problem and see if we can make it happen. It says the volume of two similar solids are 128 and 125. 250. You probably can tell the 128 is a smaller volume, so the volume of the small solid is 128 and the volume of the large solid is 250. The surface area of the large solid is 250. It's okay, the numbers came to be the same. What's the surface area of the smaller solid? Again, what's step 1? We need to find K. How do I find K? K is always found by either the two volumes given or the two areas given or the two dimensions given. Okay, so I'm going to go ahead. In this case, we are given the two volumes. So I'm going to use the two volume to find K. Again, when volumes are given, K must be cubed. Always do large over small unless otherwise specified. 250 over 128, large over small. What do I do from here? Yes, take the cube root of both sides. So K becomes 250 divided by 28. Then you take the cube root. The answer should be 1.25. That's RK. That's step 1. All right, step 2. Use the K to find the unknown. What's unknown here? Surface area. And again, since we moved from volume to surface area, K becomes squared. So K squared equal surface area large over surface area small. The surface area large is given, that's 250. Surface area small is not given, it's unknown, so that would be X. Okay? What's K cubed squared? K squared is 125, 1.25. When X is on the bottom, we divide. So X is 250 divided by 1.25 squared. The answer should roughly be 160 meters squared. Okay? All right. Moving on. Next problem. It's a different problem, so I'm going to go ahead and do it with you. 3. The surface area of pyramid Y is equal to 266.39. And then the two pyramids are similar. Determine the surface area of X. So we need to find the surface area of this pyramid. Well, I don't know what's the scale factor. Well, remember the question did say they're similar, so there must be a scale factor somehow. Step 1, find K. Well, this is pretty easy, even though we don't have enough volumes in this case, but we do have the height here and the height of y, the height of pyramid x and the height of pyramid y. Remember that the third way to find the scale factor is by using the dimensions. Okay? So k would be, now we don't really know which one is small, which one is large, but just the big number over the small number. So 12 over 8. It's the easiest way ever. It's height of y over the height of x. Okay, so it would be 12 over 8. And I simplify this by 4, I think by 4. 12 over 4 is 3, and then 8 over 4 is 2. So your k is 3 over 2. Step 2, let's use k to find the surface area. Use k to find the surface area. Now, you see what I'm saying? K to find the surface area, so that means must be k squared. And remember, you did pyramid y over pyramid x. Surface area of pyramid y over surface area of pyramid x. They must be the same. Consistency is a key in this lesson. All right, what's k? K is 3 over 2 squared. Surface area y is 266.39. It's given. Divided by surface area x is unknown. Okay, that's it. X is on the bottom. What do? I divide. So the surface area of pyramid x is 266.39 divided by 3 over 2 squared. And that will be 118.4 after you round. Feet squared. Okay. All right. Next question. The boxes below are two similar solids. Find the value of the missing dimension and support your answer. So they're similar. Find the scale factor. You cannot find any missing dimension without finding the scale factor. So find k. Well, how do I find k? I know this is different than what we've been working on. Well, here's the height, okay? I'm gonna color code each one. Here's W, and here's L. Let's use that. Now, how do I find k? Well, k is the ratio between the two known dimensions. Which one are the known dimensions? It's W. Okay, now since it never says which one is old, which one is new, always use the bigger number over the small number. So W, k can be found from the W. So it would be 7.5 over 5 from the W. And that will give us 1.5. That's our k. Now, use that k to find the missing dimension. Use k to find the h and b. All right, how? I'll show you one. Well, I did bigger over small. So always go from the big solid to the smaller solid. H over 12 is equal to k. What's k? 1.5. What happened here? K is on, H is on the top, multiply. So H here should be 12 times 1.5, which is 18 meters. Let's do it again, but with B. So K would be B over 6. What's K again? 1.5. B over 6. Multiply 6 times 1.5. So B equal 6 times 1.5 will be 9 meters. Okay. You can try 5 on your own, pause the video, come back and see if you got 5 right. Okay, now I'll give you a hint how you really do this. It says the two solids are similar packages, the areas of the ratio. What does that mean? 25 over 36, determine the height of the bigger package. Well, this means k, k squared, or k cubed. Question clearly states areas. So it is k squared. Good job. So how do I find k alone? Take the square root. So that will give us 5 over 6. Use this k to find the height. Well, I don't know which is the top, which is the bottom. Well, 5 is smaller than 6. That means the top here is the small package, and the large would be the bottom package. Okay, so instead of going h over 10, I must go 10 over h equal to 5 over 6. 10 over h equal to 5 over 6. H should be cross multiply here. So 5h, 6 times 10, that will give us 60. Divide by 5. H is 12 inches. Okay. I ended up by doing it all. Okay. Now, number 6, we only have 3 problems left, so I might as well do all 3. I know this lesson isn't easy, so it's really recommended to watch the entire video. Also, your warm-up will be selected problems from this video. The diagram below showed 2 similar cones. Determine the volume of the smaller cone. So we need to find this volume and justify your answer. Remember, your step 1 is to find, they're similar, so you need to find a scale factor. Find k. How do I find k here? Well, again, I don't know areas or volumes at all of this, but I do know the dimensions. So we can use height and height. Okay? Remember, big over small all the time unless they specify something else. So k equals 15 over 10, which is 1.5. Step 2. Well, step 2, we need to use k to find the unknown, which is the to find volume small. Well, I don't know what volume large is. Can I find it? Okay, so the key here, I can use k. I can say k cubed equal to volume large over volume small. I do know k because I found it. It's 1.5. But I have no idea what the volume large is and what's the small volume. In this case, we have to figure a way to find volume large. Is there a way to do that? Yes, there is. Now, looking at this cone, there's enough dimensions for me to use the basic volume formula to find the unknown volume. The unknown volume, 1/3 pi r squared h. Remember that from volumes of solids? So volume would be 1/3 3.14 times what's r? 6 squared, and h is 15. So once I do the math here, volume becomes 565.2 feet cubed. That's the large volume. Let's plug it here. The small volume is unknown. Okay, now again, the volume is at the bottom, the unknown, then we divide these two. So the small volume is equal to 565.2 divided by 1.5, all cubed. Okay, a little bit of math. Your answer is 167.47 feet cubed. Okay. Next question is the ratio, number 7, is the ratio between two similar cubes are 4:3. The ratio is straight given. What's the ratio here? Is our k. Do we have to find it? No, it's already given. So step 1 we can skip because k is 4/3. The smaller cube has 729 in volume. What's the volume of the larger cube? Okay, so we need to use K to find the volume. Again, when you find the volume, remember it must be K to the third power. It needs to be K cubed equal volume large over volume small. Again, 4 is bigger than 3. That means the large is on the top, the small is on the bottom. So K cubed here is 4 over 3 cubed. Volume large, I don't know. Volume small is given 729. Again, because X here is on the top, we multiply these two. You may want to find the 4/3 cube first, and the way I would do this is I would cube the 4 and cube the 3. So I get 64 over 27 equal to X over 729. If you don't have a calculator, I think we can cross multiply here. So I get 27 times X. So that would be 27X. 729 times 64. 46656. Divide 27. X is 1,728 inches cubed. Can we eliminate those steps? Of course. We can just multiply 729 times 4/3 cubed. If your calculator does it on its own, we can multiply these right away because X is on the top. We always multiply with X on the bottom. All right. Apologize. X is on the top, we always multiply. X is on the bottom, we always divide. Okay, we learned this with trigonometry. It's a nice trick to remember. Sphere A and sphere B are similar. The volume of A and B are, let's write that here. Volume A is 17. Volume of sphere B is 136. The diameter of B equals to 6 centimeters. Determine the corresponding diameter of A. This is the same as we have been doing so far. Step 1 is to find K. How do I find K here? K is, now we do have 2 volumes given. We can use that. So therefore, we can find the K cube. So K cube would be VA over VB or the other way around. It would be nice if we put the big number on the top so we eliminate any errors. So this means VB over VA, 136 over 17. Remember to take the cube root. So K cube is, oh, sorry, we took the cube root. We don't have to write. We can just write K. All right, 136 divided by 17, I get 8. Take the cube root of that. It's 2. Step 2. Use K to find diameter of B, of A. Okay. So remember, we did B over A. Therefore, when we set it up, it has to be diameter B over diameter A. So K equals diameter, use a different color. Diameter B over A. B over diameter A. K is 2. Diameter B is 6. Diameter A is unknown. X is on the bottom. What do? Divide 6 by 2. You always divide the number that's on the top of your X by the other number on the other side. So it'll be 6 over 2. So X is 30. That means diameter of sphere A is 3 units. Okay? this was the last problem of this. Uh, the lesson is fairly difficult, so please watch the entire video. You might want to try a few problems on your own and go back to the video and see if you got the answer right, or you can correct your own mistakes. If there's any questions on similar figures, please let me know. Okay, but at this time, I'm going to conclude our video. So let's go ahead and stop presenting. Please remember we're almost there, okay? Until I see you next, please stay well and healthy. Bye now.